Okay guys, welcome back. So in the last video I talked to you about a simple problems, actually two problems in which powers and indices are used. So powers and indices are used not only in the topic or in the course of powers and indices. Powers and indices are used in very much in all of the concepts of math, including trigonometry, algebra, calculus, everywhere. So powers and indices are extremely important to learn, and we have to introduce and we have to learn from the basic concepts. So I have been explaining you about the basic concepts and the related concepts of powers and indices in my previous videos. So in the last video I explained to you about two examples where powers and indices are used. So in this video I'll be talking about another two examples, and I'll be winding off with the topic of powers and indices. So these are my last two examples and very important, and I will use two examples so as to summarize all of them, not only a single concept but all of them. Alright, so if you are given something like this, if we have been given, so let's say, so let's say something like this. So x to the power half times y to the power minus 2 divided by x 3 by 2 power times y 6 by and I'll take 9 by 2 whole thing is a 1/3 root, right? So if we have been given something like this, what is the value, right? So this is x to the power half, y to the power minus 2, x to the power 3 divided by 2 times y to the power 9 divided by 2 whole thing to the power 1/3. So this means 1/3. Now you know that if you have some square root like this, that means to the power half. So if you have some other value here, that means 1 upon that value. So here is 3. So this whole term inside this root symbol is increased, right? Increased to the power 1/3. So we have taken 1/3 power of that. So what actually matters here is how to solve this. Now first of all, before solving this, now there is an x term here, there's another x term here, there's a y term here, and there's another y term here. So you can easily cancel this off. I don't mean completely cancelling off, I mean solving. Now you have some power y to the power something, here you have y to the power something, you have x something, x to the power something, x to the power something. So you can, since this is a division, you can easily solve this. For x you can easily solve for y, and then you can take the product. So that will be the basic steps of solving this. So before solving, now this is not like dividing x to the power half by x to the power 2/3, sorry, 3/2. So x to the power half divided by x to the power 1/2, 1 upon 1/2, so that means 3 by 2 is not like that. So what you have to do here is we have to first of all eliminate this root, right? Eliminate this root. So my first step of solving this will be something like this. If you have been given, so I'll have the numerator as it is, to the power half, y to the power minus 2 divided by, to eliminate the root, now you have 1/3 power here, you have a 3/3 power here, you have a 9 power here, so it will be half, it retains as it is. But I can write this whole thing first of all as whole thing to the power 1/3. So this is the power 1/3, right? Whole thing to the power 1/3. So my next step would be, now as I explained in my last video, you can easily take this 1/3 to be multiplied by this third power, and this half retains like that, and this 1/3 to be multiplied by this 9 power, and this half retains like that. So the next step would be something like this. So here will be x to the power half times y to the power minus 2 divided by, so this is x to the power 3 by 2, so that multiplied by 1/3 is 3 by 2 times 1/3 is half. So you can say this is x to the power half. And here you got y to the power 9 by 2, y to the power 9 by 2. So that multiplied by 1/3. So 9 by 2 multiplied by 1/3 is 3 by 2. So here would be y to the power 3 by 2. Right? So here x to the power half remains, and here x to the power half in the denominator as well. So these two should be cancelled out because x cannot be 0. Because if x is 0, this part will be 0 regardless of the value of y, whether y is 0 or not. So the numerator will be 0 and the denominator will be 0. So 0 by 0 is actually we don't define under math. So 0 by 0 is an error. So we can't say that x is equal to 0. So we can assume easily that x is not 0. So since x is not 0, we can cancel these two out. So this one and this one out. So what remains here is y to the power minus 2 divided by y to the power 3 by 2. Now when you come here, you have got only y's. You have completely eliminated the x's. So there are two ways of solving this. One way of solving this is either to make this minus 2 a power of a positive power by taking it to the denominator. And the second way is, since this is an division, and these two terms actually, although the powers are different, the bases are y, you can easily subtract minus 3 by 2 from this minus 2. So I'll work this sum both ways. So my first way will be the last way I talked to you. So this is equal to y to the power minus 2, and since this is a division, you have to subtract this term from this term. So minus 2 minus 3 by 2. So that will be minus 2 minus 3 by 2 is minus 7 by 2. So this would be y to the power minus 7 by 2, or you can say, when you can easily change this minus value to a positive value by taking the inverse. So that is equal to 1 upon y to the power 7 by 2. Or since y to the power 7 by 2 is also equal to 7 times half, so you can easily say this is 1 upon y to the power 7 times half is y to the power 7 whole thing to the power half. So anything to the power half is also called the square root. So you can say this is also equal to finally y to the power 1 upon y to the power 7 square root. Right? 1 upon y to the power 7 whole thing square root. So this is also equal to, since 1 is equal to the root of 1, you can also say that this is equal to whole thing 1 upon y to the power 7, and you can take the whole root. So that's one way of solving this. The next way of solving this is something like this. Now you have y to the power minus 2 here, you have y to the power 3 by 2 here. The next way of solving would be, now as I did here, the next way of solving this would be to take this minus 2 to the denominator. So this will be now 1 upon y to the power 2 times, I already have another 1 upon y to the power 3 by 2. Right? Now since this is a term of y and since this is a term of y, both these terms are of y, the base is similar but the indices of the powers are different. So what you can say is that when you multiply, now 1 times 1 is 1 actually. So this is equal to y times 2 times y times 3 by 2, is that when you divide you subtract, and when you multiply you, according to the basic theories of indices or powers and indices, what you do when you multiply is that you add up these two powers. So that will be y to the power 2 times y to the power 3 by 2 is y to the power 2 plus 3 by 2. So y to the power 2 plus 3 by 2 is y to the power 7 by 2, and y to the power 7 by 2, and finally what actually happens is that these two are now equal. So this is the answer that we got from the first method, this is the answer that we got from the second method, and since these two are equal, this will also solve to the final answer that we got here. So that's a simple example where powers and indices are used. So my next example and the last example under powers and indices would be something like this. So if you are given to solve something like this, powers of powers. So I'll take a simple example. 27 to the power x minus 3 is equal to 9 to the power x minus 4, right? So if you are given something like this, how to solve this? Now there are two ways of solving this actually. Now I have not taught you about the concepts of logarithm, so concept of logarithm will be my next topic under powers and indices, and the concepts of functions. So these are concepts of functions, and logarithms will be my next topic. So one way of solving this is through logarithms. So the next way of solving this is actually you can do with the concepts you have learned so far under powers and logarithms. So you can easily say, now as I mentioned in the last video, as I mentioned a little while ago in this video, you say, now if you are given something like this, y to the power minus 2 divided by y to the power 3 by 2 is equal to, you know that, y to the power minus 2 minus 3 by 2. So what actually happens of the converse? Now if you have something like this, how to go from here to here? Now you know how to go from here to here. So that's the direct concept of powers and indices. And how to go from this step to this step? You are going a step upwards, right? You are not solving, you are going back. So if you are given something like this, now this minus 2 is the power you get here, and 3 by 2 is the power you get here. So this minus sign gets here, because you know that if you have the same base and if you divide some base to the power something and some base another, the same base to the power another thing, if you divide these, if the bases are equal, you subtract the powers, keeping the base constant. So what you actually do here is that since this is a division, you subtract. So conversely, if you have a minus sign here, you can go back and say that you can place this base and a power on the numerator, and since this is minus, you can say, oh, this is a subtraction, you can say that you can do a division here, and this power to this base as the numerator here. So if you have y to the power a, y to the power b, you can easily say this is also equal to y to the power a minus b. Conversely, if you have something like that, y to the power a minus b, you can say you are taking the same base but the powers are different. We can say if you have y to the power a minus b, conversely this is also equal to y to the power a, and since this is a subtraction or a minus sign, divided by here b, y to the power b. So y to the power a minus b will be equal to y to the power a divided by y to the power b. So similarly, if you have something like this, in this example, 27 to the power x minus 3, 27 to the power x minus 3, if you have something like that, and 9 to the power x minus 4, what you can do is that you can say this is equal to 27 to the power x minus 3 is equal to 27 to the power x, right? 27 to the power x. Since here you get a subtraction or a minus sign, you can say this is equal to the division of 27 to the power 3. So this is 27 to the power 3, right? So here in the right hand side you can say 9 to the power x minus 4 similarly as 9 to the power x divided by 9 to the power 4. So you can say, now actually you can solve this. You may think the easiest way is logarithms, but you can still solve using the powers and indices. So how you can solve here is that either you can say 27 as 9 times 3, so that this 9 and this 3 sum will cancel, but still a problem arises because you will get a 3 here, And similarly you will cancel off this one and this one using 27 equals 9 times 3. Still you will get a 3 here. So the easiest way to solve this is to completely convert both sides into powers of 3's. So what you can do is that 27 is 3 to the power 3. So you can say this is 3 to the power 3 or cube, 3 cube to the power x divided by 27 as 3 to the power 3 to the power again 3 is equal to now so 9 to the power x is 3 squared, 9 is 3 squared, that thing to the power x divide by, so 9 is, you can say again, as 3 squared to the power 4. So here you get 3 cube to the power x, so that will be 3 to the power 3x. Here you get 3 cube, again that cube, so that will be 3 to the power 9. Here you get 3 squared to the power x, so that is 3 to the power 2x, and this is 3 to the power 8 now. So you can cancel off easily. So 3 to the power 8 and 3 to the power 9, you can easily cancel off these two, 3, and 3 to the power 3x and 3 to the power 2x as 3 to the power x. So this is also equal now, 3 to the power x by cross multiplication is equal to, by cross multiplication is equal to 3. So actually 3 is 3 to the power 1, you can say x is easily 1. Now let's see whether x is 1 by substituting here. So that's the best way to solve math problems, by substituting and going back and forth. Now this is the downward direction, and solving this to get the final result. And you can go in the upward direction and substitute whether, when x is equal to 1, whether the left hand sides and both the right hand sides are equal, and see whether the final answer you got is accurate. So when x is equal to 1, 27 to the power 1 minus 3 is equal to 27 to the power minus 2. So 27 to the power minus 2, so 27 is equal to 3 to the power 3. So when x is equal to 1, you can say that 3 to the power 3, 1 minus 3 is minus 2. So the left hand side will solve to 3 to the power minus 6. And for the right hand side, you can say 1 minus 4 is minus 3 and 9 is 3 to the power 2. So that will be 3 to the power 2 to the power minus 3, and that will be also 3 to the power minus 6. Right? So the right hand side and the left hand side, so the left hand side and the right hand side get the same value when x is equal to 1. So x is the only solution that you can get for this. So that's another simple example in which powers and indices can be used to explain the basic concepts of algebra, math, and all the topics under math. So I used this video and the last video to elaborate you some more examples in order to get a further understanding of powers and indices. So thanks for watching this video, and see you next time with a new concept on math. See you there.